So 3.1 is about solving quadratic equations. And remember, quadratic equations are equations that have an x squared in them. And that is the highest degree. So it's x squared plus something, or x squared plus something, or just x squared. But this introduces the word factoring to us. That's the word that we're going to have to use a lot. I'm going to introduce all of the factoring stuff that you guys did in Algebra 1, and I'm going to add a couple more things after that, okay? The big idea that you have to take away from this chapter is you have to think of this like a toolbox. You have to think of your ability to solve quadratic equations like a toolbox. Most of you can probably solve using the quadratic formula right now, and most of you could probably solve easier type equations using factoring right now. I'm going to take a whole bunch of extra tools and add them to your toolbox. You are allowed to solve quadratic equations almost any way you want, almost all of the time. Unless I specifically say, I need you to complete the square on this, or if I say specifically use quadratic formula. Unless I give you specific directions, you are going to do what works for you, okay? So you will do whatever works for you, and that is your job. You do your thing, okay? So that's what I want you to kind of understand. You do you, unless I specifically tell you have to do it a different way, all right? So the first way that you can solve this, and this is the only instance that you would actually graph in this chapter, is you can solve these things by graphing. Because really, when we solve for an equation, or when we solve a quadratic, we are essentially looking for, where the graph crosses the x-axis. That's what we're really looking for. So if you have your calculator in front of you and you want to solve an equation using this, that's fine. Like if you have an equation that's something that's very, very simple, and it has really nice numbers, you could solve it like this and just say there are two spots that it crosses. Those are the two spots. I know that x is going to equal something like -1, and x would equal something like +4. You can do that. The only thing that's not very nice about this is in this chapter, I'm going to force you to be exact, which means that you're going to have to leave things in radical form, which is something that you have probably done already. So you leave things in radical form, and if you have to leave something in radical form, you're not going to see where it crosses nicely on the x-axis. It's going to say like 1.357125, and it's going to keep going. You can't find mean numbers on a calculator. You can only find nice numbers. Now that being said, if you can't find something using or if it has nice numbers on a graph, you'll probably be able to factor it, and that'll be faster for most of you to solve than it would be to solve on a calculator. All right? All of this is about speed and efficiency. You choose whatever makes you the most efficient. Okay? So this one I would not do as much. If you want to do that, great. If you don't want to do that, it's up to you. Okay? The next thing is to solve by roots. And this is a unique situation. Okay? This is when there is no x term. So these are equations, or these are expressions that look something like this, where it's just x squared minus 5, where it looks like something like this. There is no x term. Most of the quadratics that we deal with are when we have things that look like this. X squared plus 3x plus 7. If we have something that looks like that, notice how that 3x in the middle is the x term. Root problems are going to be ones that don't have that x term. It's going to be an x squared and it's going to be a number, and that's what you're going to do to solve it. Okay? So in this case, if I wanted to solve this, if I had something like, so this we wouldn't be able to use roots for. But this one, we would set it equal to 0, and then we would solve. So you would say x squared minus 5 equals 0. Obviously, to solve for 5, we would move that over to the other side. So we get x squared equals 5. Then we would take the square root, and I get x equals the square root of 5. Now here's a big question, something that I need you guys to think about. If I introduce a square root, is there anything special that I have to do? Think about it. I have to what? I have to put plus or minus in front of it. Because remember, when I square something, it means I multiply it by itself, right? So if I take the square root of 5 times itself, the square root of 5, I end up with positive 5. If I take the negative square root of 5 times itself, the square root of negative 5, I end up with positive 5. When you solve these, you will still get positives even when you take two negatives and multiply them together. Okay? So this should be a pretty easy concept. Let's go through one of these examples, and then we'll call it good for today. So we've got 4x squared minus 31 equals 49. Okay? So 40, yeah. So now when we solve this, it should just be exactly like a normal equation, except at the very end, we're going to take square roots. So the first thing I would do is add 31. So then I would end up with 4x squared equals 80. Divide by 4, divide by 4, and now I get x squared equals 20. Right? So now I would square root this, and I would get x equals plus or minus the square root of 20. Now, big thing here that I want you to know is in your directions, you are going to have the words be exact. We are going to use the words be exact constantly. Okay? But that being said, we can't just stop at having a square root of something that looks like this all the time. We have to simplify it. Now, I don't know if you guys remember simplifying or not, but what we need to do is we need to try to pull perfect squares out of this equation. So if I think of the square root of 20 and I break it down into two numbers. Yeah, this is something from Algebra 1. I know it happened. Are there any perfect squares that go into 20? 4, right? 4 goes into 20, so I could write that as the square root of 4 and the square root of 5. Are there any perfect squares I can pull out of 5? No. That's done. So what I like to do with these trees is I like to simplify. So, and then when I get done simplifying, I like to circle the things that are simplified so I know to rewrite them together. So my answer would just end up with x equals plus or minus 2 square roots of 5, and that would be my final answer. Okay? I'm going to throw a couple of practice problems on Google Classroom for you guys about just roots, and then tomorrow we'll pick up with the rest of the stuff. Okay, so tomorrow or tonight will be just roots, and maybe solving by graphing if you want to try that. But moving forward, we're going to pick up on the rest of the stuff.